Good morning, dear ladies and gentlemen, dear colleagues. First of all, I would like to thank the organizers for inviting me to speak during this extremely interesting and important meeting. Unfortunately, due to my teaching responsibilities, I could not join you physically today, but I'm grateful for this opportunity to address the meeting virtually. The presentation I would like to make today on the economic consequences of soil degradation in Africa to a large extent will be based on our joint research with colleagues from IFPRI and from research institutes in several countries in Western and Eastern Africa on economics of land degradation. Soil degradation is a major development problem in many African countries. Presently, soil and land degradation hotspots were estimated to cover 1/4 of Africa's land area, with annual losses of about $60 billion. This is worrisome, especially because soil degradation affects the poorest the most, since they have a higher dependence on soils for their livelihoods. In this regard, attaining sustainable development goals in the continent would be highly challenging without significant efforts to address soil and land degradation. Before talking about soil degradation and its economic impacts in Africa, I would like to highlight these definitions of soil and land degradation. Of course, soil degradation is not the same as land degradation being a broader concept. At the same time, in the economic analysis, especially when we are talking about consequences and impacts on incomes, on food security, on poverty, looking only at soil erosion or soil nutrient depletion may provide with only limited insights about their impacts on human well-being. Hence, it is usually preferable to have a broader assessment of economic consequences of land degradation. These definitions also share a common emphasis of ecosystem services, with soil and land degradation being associated with reductions in ecosystem services. In general, soils provide with two types of ecosystem services: so-called private goods, meaning market-priced ecosystem goods and services such as food and fodder, and second category, public goods such as water cleaning, carbon storage, which do not have usually market prices, so their so-called shadow prices need to be assessed using various valuation methods. One of the major contributions of soils in terms of ecosystem services are reflected in biomass production. A recent study using declines in biomass productivity between early 1980s and early 2000s identified that about 1/4 of the terrestrial area in Africa experienced soil and land degradation over this period. Of course, this kind of studies using remotely sensed NDVI data may provide with an easy global view, but they still have numerous shortcomings in terms of methodology, in terms of measurement errors, so their results are not always 100% accurate. For example, this mapping was ground truth in several countries in Africa. The rate of accuracy was found to be about 70%. Grasslands were found to contain the highest share of soil and land degradation hotspots in Africa. Soil degradation in croplands seems especially acute in northern Africa, covering half of croplands. In sub-Saharan Africa, soil degradation was found to have occurred in about 12% of croplands. So when evaluating the economic costs of soil and land degradation, which means the losses in the value of ecosystem goods and services, we separated the cost into two categories: the cost due to changes in land use and land cover, say when forests are cut down and transformed into rangelands. Since forests provide with higher value of ecosystem services than rangelands, conversion of forests into rangelands represents net losses for society. Secondly, when land use or land cover stays the same, but the value of provided ecosystem services goes down due to soil degradation. For example, soil nutrient depletion in croplands may lead to lower yields. The analysis of satellite data shows that during the period between 2001 and 2009, there has been a strong cropland and shrubland expansion in Africa, which came to a large extent due to reduction in forests and woodlands. When forests are converted to croplands, although the value of produced private goods such as food crops may go up, but the overall value of ecosystem services in most cases are found to go down because of huge losses in non-provisioning, non-market ecosystem services, public goods that I talked about at the beginning. So the calculations of the total cost of land degradation, including both degradation due to land use and land cover change, and due to soil productivity losses on static croplands and rangelands, show that sub-Saharan Africa annually loses about $60 billion due to soil and land degradation. In fact, Africa is the continent with the highest cost of land degradation in the world. On average, about 7% equivalent of annual GDP in sub-Saharan Africa is lost due to soil and land degradation. About 46% of these losses are in food, fodder, and other provisioning goods and services. The majority, 54%, are in non-provisioning ecosystem services, which are global public goods. If we look only at soil degradation in croplands and across different regions of Africa, you can see that highest costs of soil degradation in croplands are in southern and western Africa, slightly more than $1 billion each, when considering only 3 crops: wheat, maize, and rice. For the whole sub-Saharan Africa, these costs were here estimated at about $3 billion. At the same time, there are very substantial differences in the literature in terms of assessing the cost of soil degradation in croplands. UNEP, in its report prepared for the Economics of Land Degradation Initiative, assesses the costs of soil degradation in terms of losses in cereal yields in Africa to equal about $127 billion annually. Similarly, the cost of soil degradation in rangelands was found to be slightly higher than $1 billion annually in sub-Saharan Africa, with biggest costs coming from deterioration of rangeland productivity in Central Africa and East Africa. A restoration of degraded soils and lands was found to have strong economic returns. The estimations show that every dollar invested into land restoration in sub-Saharan Africa can yield about $4 in return in a 6-year period. The numbers I talked about point at significant economic losses due to soil and land degradation in Africa. However, these are still direct costs. There are also significant indirect, often not yet quantified costs in terms of undermined food security, malnutrition, and poverty. This figure here points at a very high correlation between declines in soil productivity and malnutrition in Africa. Eradicating hunger in many countries in Africa without addressing soil degradation seems very challenging. Research conducted in Tanzania and Malawi also showed that land degradation is very much related with poverty. The poor have more degraded lands, so they are affected the most by soil degradation. Of course, the causality is usually two ways. On the one hand, the poor may have lower capacities to invest in soils. On the other hand, soil degradation may exacerbate poverty. Household surveys from Kenya show that only 40% of agricultural households adopted at least one soil-conserving, sustainable land management practice or technology, such as integrated soil fertility management with judicious application of fertilizers to avoid soil nutrient depletion. The majority, 60%, do not practice any soil-conserving measure. Soil-conserving measures often have higher rates of profitability because they contribute to higher crop yields. Here in this example of Niger, we can see that households used most often crop residues for mulching in their fields, which has the lowest profitability. The technology with the highest profitability, a combination of mulching, fertilizer, and manure application, was adopted the least. The study found that access to extension, access to non-farm jobs, meaning higher opportunity cost of family labor, were among the factors associated with adoption of soil conserving practices. Similarly, cross-country analysis of drivers of sustainable land management and adoption of soil conserving practices showed that there are several factors that consistently facilitate the adoption of soil conserving practices. These factors are access to markets, land tenure security, access to extension, and to non-farm jobs. So, what are some few conclusions on measures that may contribute to sustainable soil and land management in Africa? Bigger share of the cost of soil and land degradation were in the form of non-provisioning ecosystem services. And that means public goods. That also means that some additional incentives, for example, in the form of payments for ecosystem services, could help internalize some of the benefits of sustainable soil and land management and help catalyze their adoption. Secondly, research consistently found that such factors as land tenure security, access to markets and credits, access to extension can facilitate better management of soils and land. Finally, several examples, notably from Niger, showed that providing communities with opportunities for decentralized management of land resources may lead to more sustainable land management outcomes. Thank you very much for your attention.